Dun, dun, dun. YouTube Premium is ad-free YouTube and the YouTube Music app all together. One subscription, 2 apps. Try 1 month free.
Mic check, 1, 2. Mic check, 1, 2.
Mic check, 1, 2. Mic check, 1, 2.
Roadblock 2, we have another pickup truck heading your way. 2 copies.
All right, everybody. Welcome to day 2 of our
Can we
FOXSI
bring
window.
Iridium off?
A lot of stuff going on right now. Our roadblocks are sitting out there on the highway just waiting for the call. It sounds like they just about got the payload cold and ready to rock and roll. So it might be a matter of time that we just need the sun to cooperate and send us. Anyways, I remember to turn my speaker off when I'm talking. So it's only a matter of time. We're just waiting for the science team to say, hey, there's been a solar flare and we want to launch our rocket. Could happen anytime between now and about 5:30 this evening. So sit back, relax, enjoy the tunes, and I'll be trying to answer your questions in the chat as you have them. Just remember, I am just Dave, not Dr. Dave. So if you have any really high level type questions, I am not the person to ask. So thanks for joining us, and we'll chat at you later.
Blockhouse, Roadblock 2, vehicle has cleared.
Experiment check 5.
Hello. Thanks for the intro, Dave. To those working, listening to us at home, this is Danny and Chris. We're here at the SOC, the science team, so we can answer potentially any science questions anyone in the audience has.
Experiment check 8.
ACS check 9.
Check 10. Appendix delta is complete.
Hi, Ace.
Block 1, we have another vehicle heading your way. Block 2. 2 copies. Block 2, we have another vehicle heading your way. Two copies.
Flare forecasting today was interesting. We had an M-class flare earlier, but it went by really fast, so we probably won't have launch on it even if the launch window was open. Otherwise, kind of quiet, but hopefully it'll get more active soon.
Blockhouse, roadblock 2. Both vehicles have cleared.
Copy.
RSO checking 138, azimuth 15.1, elevation 80.2.
ACS rechecks 137. Launcher set to azimuth 15.1, elevation 80.2, recheck 139.
RSO confers.
This is CM. Temperatures on the NASROC box are negative 24 degrees and 5 degrees on the experiment box.
Can we have another event, please? Our current temperature is negative 7.6 Celsius.
Benton work.
Venting complete.
We built a $49 garden hose nozzle that makes every pressure washer on the market completely unnecessary. Every pressure washer has the same fundamental flaw, and nobody was fixing it. You see, pressure washers all rely on motors, engines, or electricity to generate force, and that works. But it also means they're loud, heavy, expensive, break after a few seasons, and need storage space most people don't have. We all know a gas pressure washer costs $400 minimum, and electric ones aren't far behind. But what if you could get the same cleaning power or more, without a motor, a cord, a gas tank, or anything that breaks? That's exactly what we built at FOXSI. We created a patented hydraulic jet accelerator that fits in the palm of your hand. Water flows through precision-cut chambers inside the nozzle that compress and accelerate it. Pure physics, zero electricity required. It's called a FOXSI, and it's nothing like any spray nozzle or pressure washer you've seen before. The hydraulic jet accelerator multiplies your garden hose pressure by 15 times. And this is a breakthrough because it means you're done with machines that cost hundreds of dollars and break when you need them most. It connects to any standard garden hose in 3 seconds. It weighs almost nothing and fits in your back pocket when you're done. And it has 8 spray patterns built in, so you can switch instantly between full jet blast and a gentle rinse depending on the surface. My team and I worked on the internal chamber design for years. We went through countless prototypes, refining the geometry of the compression chambers until the pressure output matched what industrial cleaning equipment produces. The first time I tested the final version on a driveway that hadn't been cleaned in over a decade, the concrete went from black to gray in under 15 minutes. That's when I knew we had something nobody else had built. It doesn't matter what you're cleaning: driveways, siding, patio furniture, vehicles, gutters, deck boards, second-story windows from the ground. FOXSI handles everything in under 10 minutes. The nozzle itself is solid stainless steel with no moving parts that can wear out. No motor to seize, no power cord to fry, no gas tank to drain. We're proud to say that FOXSI has a 4.8-star rating across thousands of verified reviews. Customers who spent years replacing broken pressure washers are now on their second year with the same nozzle. Zero issues. FOXSI solves the biggest problem with every pressure washer ever built: mechanical failure. What I'm most proud of is how simple it is to use. You don't need experience, storage space, or a power outlet. If you can twist a garden hose connection, you can use FOXSI. So if you've been thinking about getting a pressure washer, or you're tired of the one you have breaking down, now is the perfect time. Right now you can get FOXSI for 50% off. That's less than renting a pressure washer for a weekend. Less than paying someone to clean your driveway once. And with a 30-day money-back guarantee, you have nothing to lose. But
We hope so too, you pick 32. We hope so too.
Units a month from our factory. The current batch is already 60% gone, and spring cleaning season has everyone ordering right now. Last time we sold out, it was a 6-week wait for the next batch. Click below to get FOXSI while this batch is still available. Stop replacing machines that break, and buy the last cleaning tool you'll ever need.
It's just like a very cool way to prototype extremely quickly. If I go here in Figma, I just have this design here that I pulled together. I can just take the link, I can copy a link to selection, and then I can go into Codex and I can just paste the link. Use the Figma skill to implement the automations page in my app. It was like 90% of the way there.
RSO checking 138, azimuth 17.3, elevation 79.9, and winds are marginally green.
ACS rechecks 137. Launcher set to azimuth 17.3, elevation 79.9, recheck 139.
RSO reconfirmed.
Hi, you pick 3-2. This is Chris for the science team. The window is actually open right now. We've been open for a little bit, and we're on for 5 hours today. So hopefully it's not a long wait. We're hoping to launch soon, but we're prepared to wait the 5 hours.
Roadblock 1, roadblock 2. Here comes a pickup truck your way. Roadblock 1, copy.
Let's get to work on a life you love. Built with someone you can trust. Edward Jones.
Block 2, we have a pickup heading your way as well. 2 copies.
CMMM.
Go ahead.
PI would like to increase the pressure at the doer to 49 psi.
CM copies.
1, vehicle is clear. Vehicle is clear past roadblock 2.
Yep, 49 PSI is a good number.
Experiment MM, please confirm that your valve is completely closed and will stay that way until I say so. Experiment, did you copy?
MMCM, this is PI. We actually want to request an increase of the pressure, not to 49, but 50 PSI. If you agree, then we are gonna close. We are gonna proceed to close the shot. Oh, it's closed. It's closed. Confirm it's closed.
Okay, we will
The
increase
link to
it to
the
50 PSI,
playlist
PI,
is
but be
brought to you
advised
by
we might be going
Dave,
through
who works here at
LN2
the
at a
range.
more rapid pace
Put a lot of work
than
into
what
the
we
live
saw
stream.
earlier
Shout out
today.
to Dave.
Understood.
Okay, and you are completely closed?
Yes.
Copy.
This is PI. Can we also check the fill out level?
Yes, we're going to check the doer level as well at this time.
Thank you.
Hey, honey.
Mike, I'm packing.
Yeah, we are trying to time this with a solar flare of at least a C5 magnitude. For the people at home, if you want to look at what trying to measure, one of the websites we use is called Solar Monitor. You just Google that. We tried to paste the link in the chat and it wasn't working, but feel free to look at that website. Sun's been a little quiet today. We did get one M-class flare earlier, but it was very fast, so we wouldn't have launched on that. But I think the weather was looking good today. I don't know correct me if I'm wrong, Chris, but there was a little rain earlier today, but otherwise I think the weather's fine.
Yeah, nothing to correct here, Danny. Yeah, it looks good weather conditions at least. I think it was similar to yesterday where it was a bit variable, but it's within sort of acceptable parameters at least.
I'm a research scientist at the Space Science Lab in UC Berkeley, and I'm right now serving as the principal investigator of FOXSI-5. We are very excited to be here at the Poker Flat Research Range. We are getting prepared to integrate and put FOXSI on the rocket trail. FOXSI is the 5th iteration of the FOXSI sounding rockets. FOXSI stands for the Focusing Optics X-ray Solar Imager, and as its names indicated, is a telescope that we put as the payload of one of these sounding rockets. And the payload is fully optimized to look at the sun in X-rays. What we want to do is to observe the sun in X-rays, but not at any time, but only when there is a medium to large solar flare occurring. So every time there is a large solar flare, there is a bunch of X-rays being emitted everywhere, and we basically optimize FOXSI to catch those X-rays with the highest sensitivity.
Blockhouse, red block 2. Blue van just passed me, heading your way.
Now, more than ever before, the humanity
Block 2, vehicle heading your way.
Technologically dependent to our satellite technology, and the sun constantly emits all this plasma into the interplanetary space. Some of the times that plasma hits Earth, that plasma interacting with our planet can damage satellites, can break our technology that depends on those satellites. And by observing all these phenomena in X-rays, we can learn about the physics and the dynamics that is happening there. So the more we learn about these solar flares, the more we can prevent possible damages on our technology, and we can also learn more physics of the plasma that composes the sun. Ever since I was a child, I wondered about what those bright stars were out there. And as I grew up and I started studying my own profession, I'm a physicist, I realized that the sun was the closest star that we had, and it gave us a unique opportunity to study the stars. It's a very unique time to be a solar scientist.
Block 1, vehicle clear.
If you can go into science engineering, we need everybody.
Roadblock 2, vehicle has cleared me also.
Many technicians, administrative people, engineers, scientists, all working for the same missions. I'm Milo with Drago Casas.
Thank you for playing that, Dave. That's a video from our fearless PI, Juan Camilo Huitrago Casas. I hope I didn't butcher that too badly, but he is currently commanding and in deep focus, so we're not going to disturb him too much, but maybe we'll get a shout out from him later on in the live stream.
Oh, absolutely. Was happy to play that, and I'll play that probably a couple of times throughout the day, and of course I'll probably play it every day until we do launch. Yeah, I found that and thought it would be pretty nice to throw out there as an explanation to people as to what we're doing. So let's get some music to go back going and get some more information up here for you folks.
I believe the apex is around 300 to 400 kilometers, but Chris here is going to look up the specifics and get back to you. Rodrigo Fernandez 5825 asks, why is the focus to measure X-rays versus other wavelengths? Are they the most damaging to satellites? Well, the purpose of FOXSI is to measure X-rays, as you said. I would say X-rays in general are definitely the strongest ionizing radiation, but we study X-rays because it's sort of looking at a specific mechanism in the solar flare process, and there aren't any other instruments capable of doing what FOXSI does, which is direct imaging of the X-rays. So FOXSI is doing something very unique, which will give us some insight into a specific mechanism in the solar flare that we plan to study.
Experiment, we are back inside the blockhouse. We currently just vented the system, and now we are flowing LN2 to your box now. You are able to open that box and cool as normal.
Copy that. Thanks, MM.
RSO with number 138, azimuth 17.4, elevation 80.2.
ACS rechecks 137. Launcher set to azimuth 17.4, elevation 80.2, recheck 139.
RSO concurs.
This is Chris from the science team. Just to add on to Danny's response earlier to the apex of the rocket, or how high it will go. From the FOXSI-4 launch, just over about 2 years ago, we got up to 270 kilometres. So I think we're expecting it to be something similar again this time. This is Chris again from the science team, and Rodrigo Fernandez is asking an excellent question. How do you know that a flare is going to last long enough when you decide to launch? So we've got a bunch of tools here that we're using and keeping an eye on different parts of the sun. In direct response to that question, we're using a machine learning technique that was developed not long before the last launch, and what it does is it looks at what the flare's doing right now and is able to predict with decent accuracy how long that flare will have left. Flares can last for a whole host of different times. For example, Danny mentioned earlier that the one that we got before the launch window opened was a little bit too short, and we wouldn't have launched in that. But this software that we're using, that was made a couple of years ago, it should tell us if it's still going to be happening when the rocket gets up there to observe.
Roadblock 1, white pickup truck coming your way. Copy.
My name is Peter Elsner. I am a recovery lead for Poker Flat Research Range. So I've been working at Poker Flat since 2012 and started rocket recovery that year, and I've been doing that ever since. We're in Venati, Alaska right now, which is about 180 miles north of Fairbanks, and we're going up to get the Bailey Polar Nox payload where it landed.
This is CM to all. PI has reported that he's seeing some network issues that are slowing down his prediction tools. So if you might happen to be watching video streams on your laptop, if you could stop at this time so that we can dedicate the network bandwidth to the prediction tools that the PI is using.
Payload, which is going to be complicated today because it was damaged.
Thank you.
Hit the ground. We actually have to do some forensics on the parachute before we pack that up, and then we'll try to rig up the payload, part of the payload probably in a net that will hang under the helicopter, bring that back here, and then that's going to get taken in an airplane back to Fairbanks. It's kind of a dream job. Just go out in the woods and hike around and clean up the wilderness from science that we're doing that's really important. So it's a pretty feel-good job.
Joe McGilvery 2844 in the chat says two-stage sounding rocket, and he brings up a great point. The FOXSI rocket is a two-stage rocket with the Terrier rocket at the bottom, and then Black Brant 9, I believe, which is a Canadian rocket from Canada.
In situ pictures as I can get.
Great point, Joe.
It's a bunch of twigs covered with parachute material here. Given that it came down under a parachute, this is probably the most banged up I've ever seen one. The biggest challenge is that we can't just pick it up and take it home. Even if it stuck together in the place where you can see that it's bent, like even if it stayed together there, it would likely not fly very well. So it would be really hard for the helicopter to keep any speed going while slinging it, and maybe a little bit unsafe. So we're gonna have to get it apart into two pieces before we can get it out of here, because it's really just the only way to go at this point. So we managed to get the experiment portion of the payload separated from TM ACS, got it pushed downhill a little bit. We were going to put some Velostat fabric on the back end, but the back end is already full of dirt and all kind of garbage, and we're in a hurry at this point. We're right up against our time. So the helicopter is going to bring a net and a tarp down here. So put the net down, put the tarp on top, roll the payload into both, wrap it up, and then we'll hook it up and he'll take off. It's going to be satisfying when we get home before dark. Next step will be Venati and then hopefully home. My name is Peter Elsner. I am the recovery lead for Poker Flat Research Range. So I've been working at Poker Flat since 2012 and started rocket recovery that year and have been doing that ever since. We're in Venati, Alaska right now, which is about 180 miles north of Fairbanks, and we're going up to get the Bailey Polar Knox payload where it landed, about 45 miles northwest of here. Recovery involves a lot of planning, especially in the winter. That's all done. We're in the middle of it now. So today we're gonna, when we leave Venati, we'll fly up together with both helicopters and we'll land as close as we can to the payload, which should be pretty close because it's not in a timbered area, it's kind of out on a ridge line. And then we'll have to rig the payload, which is gonna be complicated today because it was damaged when it hit the ground. We actually have to do some forensics on the parachute before we pack that up. And then we'll try to rig up the payload, part of the payload probably in a net that will hang under the helicopter, bring that back here, and then that's going to get taken in an airplane back to Fairbanks. It's kind of a dream job, just go out in the woods and hike around and clean up the wilderness from science that we're doing.
This is PI, can we get
please
a vent?
Vent and work.
So we found the payload here right where we left it when we did our recon flight. I'm just taking a bunch of pictures for NASA. You know, we're gonna bag this parachute up and take it back to them, but you know, as many in situ pictures as I can get. It's a bunch of twigs covered with parachute material here. Given that it came down under a parachute, this is probably the most banged up I've ever seen one. The biggest challenge is that we can't just pick it up and take it home. Even if it stuck together in the place where you can see that it's bent, like even if it stayed together there, it would likely not fly very well. So it would be really hard for the helicopter to keep any speed going while slinging it, and maybe a little bit unsafe. So we're gonna have to get it apart into two pieces before we can get it out of here, because that's really just the only way to go at this point. So we managed to get the experiment portion of the payload separated from TM ACS, got it pushed downhill a little bit. We were gonna put some Velostat fabric on the back end, but the back end is already full of dirt and all kind of garbage, and we're in a hurry at this point. We're right up against our time. So the helicopter is going to bring a net and a tarp down here. So put the net down, put the tarp on top, roll the payload into both, wrap it up, and then we'll hook it up and he'll take off. It's going to be satisfying when we get home before dark. Next step will be Venati and then hopefully home.
Vent complete.
My name is Peter Elsner.
Shadow Girl 4849 asks, what are the odds of launching today? Really hard to say. It really depends on whether the sun wants to cooperate with us. I mentioned earlier that we did have a big flare earlier, M class, which is within range of the success criteria for our launch, but it's very fast. Solar flares are pretty unpredictable, even with our science and technology at the moment, so it's really hard to say. For FOXSI-4, we waited till the last day of the launch window, so
RSO rechecking 138, azimuth 15.7, elevation 80.5.
ACS rechecks 137. Launcher set to azimuth 15.7, elevation 80.5, recheck 139.
RSO confirmed.
This is PI. Can we get another vent, please?
This is Chris again from the science team to the live stream. I see that we've just had a comment asking if we can't launch in the next 2 weeks, will you wait until next winter for FOXSI? So as it stands right now, and I think pretty much permanently, we only have this 2 week period. I think the last day that we can launch is the 15th of May. We'll be having these 5-hour windows almost every day between now and then. But those are the only days. That's the only time that we have to launch FOXSI-5. We will. I don't think that we're going to get any other time, which might sound a bit scary, but I think that the sun is really quite active in general, even though that we've not seen some flares that we've wanted to see. And in contrast to FOXSI-4 a couple of years ago, the sun is far more active than what it was at the same time, and we still had a very, very successful mission. So no, we won't get any time after this 2 week period, but I think a lot of the team are very confident that we would need to ask for it, I think.
Roadblock 1, roadblock 2, you got 2 cars coming your way. Copy that. Both vehicles have cleared roadblock 1.
This is PI. We would like to increase the pressure to 55 psi, please.
Copy that. When I tell you we'll have to go completely closed with the valve and steady state,
We'll do that.
stand by for that. For reference, Nazarok box temperature is -65 and dropping. Experiment outlet is 10 degrees Fahrenheit and dropping.
Copy that. PI here, a quick solar activity report status. So we got, a few minutes ago, we got some early warnings. I didn't call them. We were in red for experiment, but activity turned over already, so that seems to be a small flare, probably a C1 flare, C2.3 flare.
Copy. Thanks for the update, PI. Would you like us to go ahead and increase that valve pressure now? PI experiment.
Working on it.
This is experiment. The valve is completely shut. Copy that. We will go out and change the pressure.
PI here, also with another report. The internet speed issues that we are facing today are so severe that our tools to track solar activity are basically very affected. We cannot get real-time information that will let us know that a solar flare is happening. To complement that, we may miss a flare if we continue having these internet issues.
This is CM to all. We're still seeing network issues. So the next thing I think we'd like to try is if you are in a government computer and you're connected to the VPN, if you go ahead and drop the VPN, I think if your computer is like my computer, it often does automatic backups through the VPN. You can also try pausing. Mine is called Druva service or something, and so if you can also pause that backup.
Experiment MM, you are clear to begin cooling operations again.
This is Experiment. We are trying to ramp down again.
Copy.
Roadblock 2, vehicle heading your way.
2 copies.
Experiment MM, we'd like to vent.
Sounds good.
Vent stopped.
This is Roadblock 2, vehicle has cleared my location.
RSO with number 138 when weighted launcher settings, azimuth 11.9, elevation 80.4.
ACS rechecks 137.
Roadblock 2, there's another vehicle heading your way.
2 copies.
Make that 2 vehicles heading your way.
2 copies, 2 vehicles.
Launcher set to azimuth 11.9, elevation 80.4, recheck 139.
Are so confirmed.
This is Roadblock 2. Vehicles 1 and 2 have cleared my location.
Hi, this is Chris from the science team again. To the live chat, we've got another question from Ace. Is in last place, and it's what is the rationale behind picking the poker flat launch spot over other spots? So for FOXSI, there's not really a specific science reason. We were supposed to be flying out of White Sands in New Mexico, but for logistical reasons and other reasons, we ended up moving up here to Alaska. For other missions, it's really important. The location is very important. Of course, Aurora missions, there's a lot of those that come out of Alaska for good reasons. Alaska gets good Aurora. But yeah, for us, it was a logistical choice, mainly. There are some benefits where we're perhaps a bit less restricted in Alaska, considering it's not a military base like the one in New Mexico is. But yeah, hopefully that answers your question. Danny, do you have any thoughts? Yeah.
I was just gonna ask what your thoughts are on the last name, on the username, Aces in last place. I think that's quite harsh. I feel like Aces should be in first place.
Well, if we're looking at the rankings in the chat, I think it's Aces in last place is false. She's actually way up in first. So yeah, it's a bit of a tricky situation there for us, Danny, right?
I can't agree more.
Block 2, vehicles heading your way.
2 copies.
a great attitude to have, Ace. Great attitude indeed.
Block 2, I got a pickup truck heading your way.
2 copies. Block 2, first vehicle has cleared my location. Roadblock 1, you have a blue pickup coming your direction. Over that.
Shadowgirl4849 asks, what is the best place to view when you guys launch? I think that's a bit of a subjective question. Us here at the SOC, which is the Science Operations Center, is we're at the top of a hill, so we get quite a nice view. We have to rush out of the building and stand on some railings to look down at the rocket launch. That's pretty nice. The NASROC people are down closer to the rocket, so they might get a good view. I think Dave plans on switching the live stream to a wide shot for the view, so hopefully you guys back at home will get some nice rocket launch viewing as well. Joe in the chat has a suggestion for where to view the launch. I personally haven't heard of that place, but this is also my first rocket launch, so I bet Joe has more experience viewing than I do, so I would take his word for it. Ace in the chat brings up a great point about doing 2 rockets at once. In FOXSI-4, we actually launched a companion rocket called High C, but for our current campaign, FOXSI-5, we are launching alone. I think this is just due to some logistical constraints on our end. So maybe next time, FOXSI-6, like Ace suggests, we'll have friends. Shadow Girl asked a good question. Does it matter which pad you launch out of? So we are actually launching out of a different pad than in FOXSI-4. And there are slight differences between the pads, and it does constrain the rocket a little bit, but for the purposes of FOXSI, it does not matter much. It's just different launchers between the two pads, and that didn't have a big difference on our science payload. It just made a difference for the NASROC folks who are in charge of preparing the rocket for us.
Roadblock 1, you have one SUV coming your way. One SUV, copy that.
2, you have one on your way as well.
2 copies.
Hey, Isabella Wong - Berkeley. What do you mean by your question, how does measuring work?
Block 1 is clear.
Vehicle is cleared, blockhouse, or roadblock 2.
So when FOXSI-5 exits the Earth's atmosphere, we're going to take imaging of the sun, direct imaging of the sun in the X-ray regime. On board we have 7 different detectors with 7 different optics, each one measuring slightly different parameters, and they will be collecting photons that are being sent directly from the sun to create an image. For more specifics, we have 3 different types of detectors on board. We have a CMOS detector, a CAD detector, and an appendix detector.
And just adding on to what Danny said there, these are also detectors that are widely used for medical purposes and other scientific purposes. So, for example, the Time-Pix detector that Danny mentioned is used in CERN for the Large Hadron Collider in particle physics, and then also the CAD-TEL detectors are used in hospitals that some of you may have been sent for an X-ray before. So we're using them, our very modern versions of those, for testing purposes for future spacecraft, and the sun will emit X-rays when a solar flare happens, and we'll use those detectors to see what the sun looks like, as Danny said.
And correct me if I'm wrong, but I'm pretty sure the recent Artemis mission, on board they had some CAD-TEL measuring for cosmic rays to test, see how much radiation the astronauts received during their flight to the moon. So.
I didn't know that, but that sounds pretty cool. So, yeah, I can't correct you, but so I don't know if you're wrong, but I believe you, Danny.
I appreciate it, Chris.
There's a red pickup truck coming your way.
2 copies.
And a car behind him.
Copy, 2 coming my way. This is roadblock 2. Both vehicles have cleared my location. And Tony, you've got one white truck coming your way. Roger. Roadblock 1 red pickup truck coming your direction. Roger.
Base 44 Super.
White truck is clear. Red truck is clear.
Experiment check 5.
PTM check 6.
TLC check 7.
Experiment check 8.
ACS check 9.
Check 10. Appendix Delta is complete.
RSO checking 138, azimuth 12.9, elevation 81.0.
ACS rechecks 137. Launcher set to azimuth 12.9, elevation 81.0, read check 139.
RSO confirmed.
Hi, this is Chris again from the Science Operations Centre. We've got a good question here from Isabella Wang at Berkeley. What is the radio checks? So pretty much you'll hear a lot of chatter over the radio, some from the science team, some from the team down much closer to the rocket. Effectively throughout the window, we will be constantly monitoring our systems. Sometimes that means that we will restart systems or just clear data so that we're not taking up a lot of storage space on board. So we know that we'll capture all the data from our flight. So there's a bunch of reasons for the radio checks. Some are scheduled, other ones just it's like a situation arises that we might want clarification on.
Copy, thanks, BI.
So hopefully that answers the question. Hi, this is Chris again, and I've seen that there's a lot of excellent questions coming in here. One from Shadow Girl 4849. Does the temperature matter in outer space when launching? That's a really good question, and we could probably talk about that for quite a while. So obviously it will be really cold up there. So we make sure at least that the important parts of our instrument, and when I say important parts, I mainly mean the detectors themselves, they can be fragile to different temperatures. So those are insulated really well and under quite a good bit of temperature control up there. So that's one thing about it. We actually prefer the detectors being quite cold. That helps them operate better. And then the other side to that, so that's the coldness of space, but we are using optics on board, so that's going to be focusing quite a lot of sunlight down into the detectors. And you can imagine that gets pretty hot. So around the optics in the front of the telescope, we also have what we call thermal blanketing, which sort of helps maintain the temperature around the whole rocket to stop it getting too warm as well. There. I don't know if Danny wants to come in and add to that.
I was also going to say today, you might have heard a lot talk about the pressure switching from 49 to 50 to 55 psi. So on the rail, we have a cooling system that is attached to a dewar. And so this pressure is basically the pressure coming out of the dewar into the system. And there are certain times today where our detectors weren't getting cold enough. We have the specific detector of CMOS, which operates at minus 20 Celsius, I believe-ish.
And CAD-TEL, yep.
And CAD-TEL. So they operate at these low temperatures, so we need pumped liquid nitrogen and N2 into the system to cool it down. And so earlier today, it wasn't getting cold enough. We were worried that the dewars weren't pushing hard enough to get the liquid nitrogen to where it needs to be, so that's why we were increasing the pressure. Of course, this comes with the trade-off. When you increase the pressure, the amount of liquid that flows is a lot more, so the dewars run out a lot faster. And so sometimes we have to switch out the dewars in the middle of the launch window, which causes a pause in the launch window, which is something we ideally avoid, but sometimes is unavoidable in order to operate the rocket at the parameters that we want it to.
This is roadblock 2. First vehicle turned down the driveway right in front of me, and the other two have passed me.
roadblock 1, this is Blockhouse. They turned into the lodge?
Negative, this is roadblock 2. The first vehicle turned down the driveway across from where I'm staged at.
Okay, are they behind you? I'm just trying to figure out where exactly, which driveway it is.
I do not know, but it's the driveway that's exactly across from mile marker 31.
All right, copy.
Kyle, that's the watershed road.
Okay, all right.
Do you need me to go down there?
Yeah, that's inside the hazard area once they get closer to the bridge. We posted a sign there on the bridge itself, but they won't see it until they reach the bridge.
Roger, I'm heading down there.
Thank you.
This is roadblock 2, 1 white pickup truck coming towards you. Copy that. Roadblock 1 clear.
Agents. The next thing.
What would you tell?
This is what walking does to your joints after 50.
Alright, so I just seen a question coming in from Ace again, who's ironically in first place. Any updates on the networking issue Milo mentioned? So we've literally just been talking to our PI right now. He's a little bit shy. If you want to hear him on the radio, you might need to cheer a little bit louder for him to come on. But pretty much what he was saying there about the networking issue is that they're still exploring some options. It's not stopped us being able to use our tools completely. We're still good to go. It just might mean that some of the more smaller flares, it would be trickier to catch them in time. So we're just trying to pretty much solve the issue of making these tools as good as they can be, but they're still working pretty well the way that they are. So I don't want anyone to panic there. And yes, come on, Milo. That's it. That's good. We need more of that, and we'll get them on. Thank you.
Blockhouse, I spoke with this truck down the Watershed Road. He's coming back with me.
This is roadblock 2. Red pickup has cleared my location.
Blockhouse copies.
Roadblock 1, you have a orange car coming your direction, and then Tony also. Copy. Block 2, you have a pickup heading your way. 2 copies. Tony's hanging out here for a little while, so you won't see him for a few. Copy that. One is clear. Roadblock 2, pickup truck has cleared my location. Blockhouse, the truck that went down the Watershed Road is clear.
Copy, thanks, sir.
Roadblock 1, Tony is now heading your direction. Copy that.
RSO with a new 138, azimuth 15.4, elevation 81.0.
ACS rechecks 137. Launcher set to azimuth 15.4, elevation 81.0. Check 139.
RSO confirmed.
Roadblock 1, white pickup heading your direction. Copy.
1 is clear.
Roadblock 1, you got a red pickup coming your direction. Copy.
Hey, Joe needs to block out. Joni, do you copy? Block out.
Go ahead.
Hey, can you call me at 2106?
Yep.
Red pickup truck clear. Roadblock 1, you have one motorcycle heading your direction. Copy that. Roadblock 1, you have a maroon pickup truck heading your direction. Copy that. Motorcycle clear, roadblock 1.
pickup truck clear roadblock 1.
Hi, this is Chris from the Science Operations Centre again to the live stream. We have actually managed to get our PI here due to the chance in the chat. So Milo's going to give a
Roadblock
brief
1,
update
blue pickup truck
on
heading your direction.
how he's feeling. Milo, here you go.
Copy.
And thank you, Chris and Danny, and thank you everybody who's listening. No, things are much better now, so we are currently green for the experiment. The whole experiment is working and ready anytime we see solar activity to ramp up. And our solar flare monitor team got a pathway to monitor the occurrence of any large or medium solar flare. So basically we are pretty ready and waiting for the sun to get a little more spicy. That was our fearless PI, Milo, and he's already running away back to his work. But thank you, Milo, for tuning in. Here's to hoping the sun cooperates with us. And thank you all back home who are listening in to the live stream right now.
Roadblock 1 cleared with blue pickup truck.
RSO with a new 138, azimuth 11.7, elevation 80.7.
ACS rechecks 137.
Hi there, it's Chris from the Science Operations Centre again to answer some questions that are coming in. Although, yes, we will tell Milo, thanks for saying hi. He was very nervous, but he was very encouraged when he saw the messages pouring in, and also the offer of a free lunch from you, Ace, I think probably pushed him over the edge to jump on, so thank you there. I see Isabella Wang at Berkeley has asked a really good question here. When we decide to press the button, how long will it spend in the air? So in total, from launch to landing, when the rocket will go up and come back down, we're looking at something around 8 minutes, or 8 minutes, or reading here, maybe up to 9 minutes. That's about 560 seconds. I'm just looking at the flight timeline here as I'm explaining this to you. So when we hit 0 for launch, it'll take just over a minute to get up to the point that we'll actually be able to observe the sun, so about 1 minute 15 seconds. And that's when our observation time will start, when we're above a bunch of the solar atmosphere. And then what we'll get is about 6 minutes worth of an observation, maybe a little bit longer, maybe a little bit shorter. So after we start our observation at about 1 minute 15 seconds, at 7 minutes 40 seconds, that's when the observation will end, because we'll start to be coming back down effectively, and then we'll land. So yeah, there's quite a few different steps. That was a really good question. So we're spending about 9 minutes in the air, and there's about 6 minutes in that 9 minutes that we'll actually be observed for.
Chris, can you imagine doing all this work for 6 minutes of data? We must be out of our mind.
Well, Danny, I don't have to imagine, and you don't either. That's exactly what we're doing. That's what we're all here for. It does seem a little bit crazy to be doing all that work, right? But because, well, it's a bit easy for us to sort of advocate for looking at the sun in X-rays, but one of the reasons why we do that is because of the wealth of data that you get by observing the sun in X-rays. It gets a lot of things that we just don't know what's going on in the sun. FOXSI-5 is hopefully going to illuminate that for us. And so 6 minutes doesn't seem like a lot, but especially with the other tools, when we catch that right part of the flare, that'll actually, or it should give us quite a lot of insight into just flare physics that we've not been capable of ever before. So it's a very important 6 minutes.
And for those of you at home, we're also measuring X-rays, which is notoriously low in the amount of data we get throughout astronomy, to the point where radio people will measure their flux in other units, but X-rays are often just photons, just individual photons, because that's all we can get.
Yeah, that's one of the challenges, and for one reason why X-rays are really good for medical purposes, because they're very good at going through a lot of material, right? And that's how you can get images of what's going on in your body. It's quite difficult to stop them in the other end, to actually detect them and realise that you've got an X-ray. So that's why it's a lot of specialised equipment, and yeah, there's a lot of specific challenges to that. And in analysing the data as well, on the other end, it's quite it's quite unique. But yeah, we're up to the challenge anyway.
Hope so.
Yeah. And I've just seen another question come in here about are there any flares? There aren't any flares yet. We've not had any since the opening of this window. But like I said, we're still monitoring the sun very closely. We mentioned earlier that there's a website that you can all check out if you Google solar monitor. It'll sort of give you daily images of the sun, and you can see it's active. We're keeping an eye on some specific regions that we've got our eye on that we're hoping to flare soon. But yeah, no flares yet that we can see anyway.
This is PI. We would like to officially request having someone checking our doors down there.
Copy that.
Please let the experiment know when do you want to shut the cooler.
Will do.
This is CM to all. While they're going out to check the doer levels, this would be a good time if everybody needs to take a bathroom break or a food break.
What are the good people at home?
Experiment MM, please
Like-
close the valve and no power switching, no change in state.
Sorry, it seems like the NASROC folks are going to go check the doers. So
Copy that. The valve
Few of
is
us can
closed,
go
and we won't do
maybe get
anything
some food
power-wise.
and a little break.
Copy that,
while
they're going
they
out to the
check
pad.
The doers.
PIMM.
This is experiment PI. Oh, here he comes.
PI here.
The doer is a little over a quarter full.
Copy that.
For reference, that check took 5 minutes. We can continue checking it periodically more often, or we would have to stop cooling operations to perform a refill or swap.
Copy that.
This is experiment. Am I in a place to be able to continue cooling again while we discuss this?
Yes, you are.
Copy that. Thank you.
Block 1 to Block 2, vehicle heading your way. Two copies. Roadblock 2, black car has cleared my position.
Blockhouse, this is Dave. You got a copy?
Yeah, go for Blockhouse.
Hey, just be advised, me and Austin are heading back down the hill, so we'll be going through the roadblock area, and I'm going to stop at Blockhouse and update you.
Okay, stand by.
Copy, standing by.
RSO, poker on 1.
This is RSO.
Hey, just be advised, we've got a couple folks coming down from SOC that are coming down to the blockhouse. So we'll be bypassing the roadblock.
Block 1 to Block 2, vehicle heading your way.
Sorry, got stepped on. It's
2 copies.
Is that okay?
Affirm.
All right, copy all. Hey, Dave, you're good to proceed.
Dave copies, me and Austin are good to proceed.
Roadblock 2, vehicle has cleared my position.
Roadblocks 1 and 2. You guys doing okay, or do you need a break?
I'm down to switch if you guys want to.
RSO with a new 138.
You go out and relieve Daniel.
0.4.
Yeah, I can do that. Sounds good.
ACS trucks
Copy that.
137.
If you want, stop by the office, get you a drink or whatever, and then head out and give him a little break.
Copy that.
Launcher set to azimuth 9.6, elevation 80.4. Recheck 139.
RSO confirmed.
Roadblock 1 to Roadblock 2, pickup truck heading your way.
2 copies. Roadblock 2, pickup truck has cleared my location.
Experiment MM, please close the valve and do not touch it. Copy that. Okay, the valve is closed.
Base 44
Copy, thank you.
agents. The next thing you can't live without. No setup. Just say hello. Every tool you already use, plugged in a click. And away it goes. Analyzing the competition. And delivering a brief before you finished your morning coffee. Sit back while it understands your portfolio. Builds and tracks dashboards and finds your next big thing. Scaling your voice. Turning your vision into the perfect post. The perfect timing. And every bit of data into a decision. All while clearing up your email, scheduling meetings, and reminding you of the important stuff. At night, it keeps on going, doing it all. So when you wake up, you're already one step ahead. Time to update what you think is possible. Base 44 Super Agents. Did you get it?
Mark, we're barely making it this month. The car payment is late. The mortgage is due next week.
I know. I don't know what else to do. I'm trying everything.
You haven't had a raise in over 2 years. Talk to your boss tomorrow. Just ask.
Okay, tomorrow I'll ask. I've been here 3 years. I show up, I deliver, I'm reliable. I'd like to talk about a raise. Mark, I appreciate that. But let me ask you something first. Are you already mastering AI tools like your colleagues? Not really. Not yet. That's the issue. I can't justify a raise for someone who isn't there yet. I'm sorry. Did he seriously just ask for a raise? Man.
Did you get it?
New car again. His wife came home the other day with Louis Vuitton bags. Their kids are in private school. Would I work just as hard? What's he doing that I'm not?
I'm gonna find out. Give me 1 day. I brought you a homemade pie. Come in, I just made coffee. So, what does your husband do if you don't mind me asking? He's in marketing. But honestly, just over a year ago, we were going through a really hard time. Debt, nothing but stress. What changed? He found this app, Coursive. It teaches you how to actually use AI, not just ChatGPT for everything, but the right tool for the right task. His boss noticed immediately. And is it hard to learn?
I'm a
That's what
research
he
scientist
thought.
at the
But
Space
it's a
Science Lab in
28-day
UC
challenge.
Berkeley, and I'm right now serving as the principal investigator of FOXSI-5. We are very excited to be here at the Focus Flat Research Range. We are getting prepared to integrate and put FOXSI on the walking trail.
Great SUV headed towards you. Two copies.
This is roadblock 2. Gray car has cleared my location.
RSO with 138, azimuth 11.3, elevation 81.0. RSO would also like to point out that balloon 15 has us trending right.
Roadblock 1, this is Roadblock 2. You have 2 vehicles heading your way, 1 truck and 1 car. Copy. Truck has passed. And now car has passed. That Jeep headed your way, Roadblock 2. 2 copies.
green pickup truck headed towards roadblock 2. Copy that. Red Jeep just passed my location. Roadblock 2, vehicle just cleared my location.
Okay, so we have a question asking about how they seal the styrofoam box for the rocket. So there's little pegs up there, little threaded rod, if you will, that the box is poked into, and we just use washers and wing nuts to hold it up there. The actual holding of the pieces together, we use spray foam. So I don't know. Let me see if I can. I'm going to zoom in on one of the cameras here and see if we can get up close enough to actually see the spray foam holding the box together. So bear with me. Give me just a couple minutes, and we'll show it to you.
Experiment MM, you're clear to begin cooling again. Copy that. Experiment MM, we're going to go ahead and do a vent as well.
Okay,
Copy
so those watching here, let me see. Let me get this over. Give me just a minute. I'm going to bring up camera here to show you the spray foam.
MM, this is CM.
Go ahead.
We may want to hit a vent. We're at negative 30 on the NAS.
CM, MM, we just finished our vent. Should be going down soon.
Awesome. Thank you, MM.
Mike, pickup truck headed your way, roadblock 2.
Can we get a reading of the doer's parameters?
2 copies.
Full status, filling status, and pressure.
Yes, Dewar is at 3/4 full, and we kept the pressure at 55 psi, or thereabout.
Copy that, thanks.
And we are at negative 64 on the NASROC box, 21 positive on the experiment box.
Block 2, silver pickup has cleared my position.
Now down to negative 72 on NASROC box, 7 positive on experiment box.
Roadblock 1, SUV heading your way.
Roadblock 1, copy. SUV has passed.
Testing, testing, 1, 2, 3. All right, we're going to take a little break from the music. I'm going to play those videos for you again here in just a second. The first one will be our PI giving his little talk in this video done by the Geophysical Institute.
I'm Milo Buitrago-Casas. I'm a research scientist at the Space Science Lab in UC Berkeley, and I'm right now serving as the principal investigator of FOXSI-5. We are very excited to be here at the Poker Flat Research Range. We are getting prepared to integrate and put FOXSI on the rocket trail. FOXSI is the 5th iteration of the FOXSI sounding rockets. FOXSI stands for the Focusing Optics X-ray Solar Imager, and as its names indicated, is a telescope that we put as the payload of one of these sounding rockets. And the payload is fully optimized to look at the sun in X-rays. What we want to do is to observe the sun in X-rays, but not at any time, but only when there is a medium to large solar flare occurring. So every time there is a large solar flare, there is a bunch of X-rays being emitted everywhere, and we basically optimize FOXSI to catch those X-rays with the highest sensitivity so far and the highest dynamic range. Now, more than ever before, the humanity, we are technologically dependent to our satellite technology, and the sun constantly emits all this plasma into the interplanetary space. Some of the times that plasma hits Earth, that plasma interacting with our planet can damage satellites, can break our technology that depends on those satellites. And by observing all these phenomena in X-rays, we can learn about the physics and the dynamics that is happening there. So the more we learn about these solar flares, the more we can prevent possible damages on our technology, and we can also learn more physics of the plasma that composes the sun. Ever since I was a child, I wondered about what those bright stars were out there. And as I grew up and I started studying my own profession, I'm a physicist, I realized that the sun was the closest star that we had, and it gave us a unique opportunity to study the stars. It's a very unique time to be a solar scientist, and everybody watching this, like if you can go into science engineering, we need everybody here contributing. There are many technicians, administrative people, engineers, scientists, all working for the same missions.
My name is Peter Eldman. I'm the federal lead for FOXSI-5.
Stream, I've seen that some stuff's come in. As I can see that Dave's kept on top of answering some questions. There's pretty much no update here. We're just sort of waiting. We had to change the liquid nitrogen cooling dewar, and we are almost back to being launch ready, which is good. So there's not really an update here on that. I see a question from Joe, which is why do they call them sounding rockets? So I think the last time during FOXSI-4 I had looked this up, and as far as I'm aware, the reason is it comes from the same root as to say to sound something out or to try and work out what's going on, and so that's why they're called sounding rockets, because they're just there to go and try and monitor something quickly to find out what's going on. I don't know if the definition has got broader since or not, but yeah, that's what
sounding rockets come.
Perspective, Chris. I had always thought that it related to like sounding as like a nautical term.
It does. So sounding as in the nautical term.
First for like ocean stuff to measure depths in the ocean, and then that term then got brought up for rockets. Maybe for a similar root, like maybe your idea gave root to the how sounding is used the ocean, and then we extended it to the skies. Makes sense to me, at least.
Yeah, you guys, you're right
Yeah,
on
I mean,
that.
I suppose
So
that's a
sounding is
logical way
to
because
sound.
I think I stopped when I saw the phrase to sound something out as to try and work out what's going on. So I mean, that's probably got a root in something that it could make sense if it's got maybe a nautical origin. But at least that's where that's the term, or that's what sounding means in sounding rocket at least. There, yeah.
Okay, we also have a question out there. The roadblocks are out, so typically that means launch likelihood is pretty good. Well,
In terms of how
during
we're looking
Aurora,
for
that
today,
would be true.
got about an hour left on the
what are they
window for
saying?
the day. Other than that, we'll let you know when they finish switching out the doer. But for those at home, sit tight, stay comfortable.
Okay, so
And
now
also
everybody
stay
has done
excited,
talking.
of course. That's what we're trying to do here.
Yeah, that's the most important.
In the operations center, yep.
Maintain a solid attitude.
Exactly. The time goes in much quicker. Yeah, we are still monitoring the sun. Again, there's some places that look quite active and they could still go off at any time. That's one of the challenges of why we want to launch and why no one else does this type of observation, right? We're sitting waiting for the sun that's quite unpredictable, and we're waiting to launch on it and try to work out the processes that are happening so it then becomes predictable. So that's what we'll be doing for the next hour, and we also have an update for their planning tomorrow. Oh no, Dave's talking over. Sorry, Dave, I can't hear the live stream at the minute.
Azimuth 12.1.
No, I think it's me that usually has to shut up, Dave. That's sorry about that.
Thanks for that update, Dave. And I see here that Climate Viewer in the chat has a question. What's the payload this evening? The payload is the FOXSI-5 science payload. It is a mission intending to directly measure
Go ahead, PI.
X-rays from solar flares. It has 7 detectors on board with 7
switch
optics.
to Appendix Delta, everyone, and this would be an opportunity for a break if you have not had one in a while.
Experiment check 1.
ACS checks 2.
BTM check 3.
ACS checks 4.
Yes, I just wanted to add on there what Dave and Joe have said about us not being in the same room. So Danny and I are in the same room, but Dave is in another completely different building. One of the reasons why we've got some science members on the live stream that Dave set up is because one, we want to sort of interact with people and let people know what we're doing, but we're also using this live stream for scientific purposes. We are using this live stream to provide as live as possible updates to some observatories that are across the US that are waiting and watching the sun with us. And as soon as we launch this live stream, will then give them the latest information on where they should look. So that's why we're on the live stream up at the Science Operations Centre, and then Dave's in another room. So that was the source of me accidentally talking at the same time as Dave earlier. But that's some context for that.
Thanks very much, Dave. We'll keep the people at home busy. Hey, Climate Viewer. I'm not quite sure what you're asking, but I could clarify a bit more about what FOXSI-5 is intending on doing. So, FOXSI-5 aims to measure solar flares of at least a C5 magnitude. We have optics for direct imaging of the sun, and we have, because we're measuring X-rays, we have special optics that will reflect the photons to our detectors. So we have these optics called Walter 1
Okay,
mirrors.
Craig, I am heading out the gate to bring your release down to you.
Chandra used Walter 1.
2 copies.
Chandra did, yep, and also NuSTAR, the nuclear spectroscopic imager. Nope. Telescopic array. NuSTAR, yes. I should have known that. That was a big part of my PhD. So, whoops. I'm glad this isn't going out to a bunch of people right now. But yeah, so there's a couple of telescopes that already use these things. An important difference, though, is that these are astrophysical telescopes for looking outside, mostly outside the solar system, definitely not really at the sun. They don't cope. NuSTAR could cope a little bit if it was very dim, the sun, if it wasn't doing a lot of activity. If it got moderate at all, it just couldn't look at the sun at all. So that's where FOXSI steps in, and I'll hand it back to Danny there to keep going with the explanation.
Yeah, there's another good question from the chat. I'm going to totally butcher this name. I'm so sorry. It's from Konstantinos Genies. They ask, is there any sort of orientation system aboard FOXSI? How do you point it at the sun in flight? So we have a Spark system, which is NASA built, I believe. There's a system on board called LIST. We actually have the person in charge right by us, but he's quite camera shy, even more so than Milo, I've heard. So he won't be answering any questions from us.
Experiment check 5.
But that basically has a sensor that measures the brightness of the sun, points at it, and every morning we give him a list of coordinates on the sun. And with those coordinates, he's able to do some pointing while we are taking measurements. And super critical for this because FOXSI has a big field of view, but
check
not that
10,
big.
Appendix Delta is complete.
ACS rechecks 140.
Hi, this is Chris again. Yeah, so thanks for the clarification, Climate Viewer. That's a really good question, but we will not be doing that with this rocket. We're remote observing, effectively, so we're just looking to get good height on the rocket for our 5 to 6 minute launch or observation time when the rocket's in the air and above the atmosphere, and we'll be pointing the telescope directly at the sun. And yeah, so there won't be any chemical release or anything like that in that sense. So thanks for clarifying that. That's actually a real interesting question. I didn't realise that happened, or rockets did that.
For the people at home, we actually have a very special treat for you guys. Our very own Julie is coming in. She's in charge of planning all the targets and looking at the flare monitoring, which is basically like knowing when flares are happening and telling Milo, our fearless PI, when to launch and all that. So without further ado, here's Julie.
Hi everyone, my name is Julie Biebering and I'm the project scientist for FOXSI. I work at the Johns Hopkins Physics Laboratory as a solar physicist. So I've been working on leading our flare alert system with the team here, and so we basically developed a set of tools that help us to understand what's happening on the sun in real time, so that we can make appropriate decisions about when to launch to observe a great flare for our mission.
Thank you so much, Julie. A quick question. Everyone's been asking, what size of flare do you think we'll see for FOXSI-5?
Ooh, a prediction. Wow. Oh, that's exciting. So we're looking for something at least C5 magnitude, and so that's based off of the GOES X-ray instrument classification scale for flares. And so that's sort of like a middle-sized flare. Of course, we would be pretty excited to have an even bigger one, and maybe something even long-lasting. So something over probably around 20 minutes, so that we have enough time to see the flare start and then still have time to do our countdown and launch to observe the whole thing. So we're looking for a large, long-duration flare. Maybe for prediction, what size flare do I want? Maybe like should we go bigger than FOXSI-4? So FOXSI-4 had an M1 flare, so we could go for like an M5 would be awesome.
Ooh, bold prediction. I like it. I was hearing from around the science team that FOXSI isn't necessarily well equipped for super big flares, so X classes. We aren't optimized for that. Do you want to speak a little bit on that, or maybe someone else can take a stab at that question?
Has passed.
Oh yeah. So there are issues if your flare is too big and your instrument isn't configured for it. So for instance, we have detectors that basically measure the X-rays that we're getting focused by our optics into the instrument, and if there are too many of those, that can overload our detectors. We do have Chris here who has worked maybe more on the detectors recently. I'll give it to Chris to say what size flare we can handle.
The last truck has passed.
Thanks, Julie. I wasn't expecting to be roped in here, but that's fine. I'll give it a shot. Yeah, so I'm not entirely sure exactly what level. I know that if we go up to an X-class flare, I think that starts to present some potential issues for us. An X-class flare is 10 times as bright as an M-class flare. It works in in a magnitude scale.
For the people at home, Chris, can you go through the list of the letters? Because I know it's not just the alphabet.
No, you're right. It uses the alphabet, but it isn't just the alphabet. No, that's fair. So we start off with really the ones that we're interested in is a C-class flare, which is the weakest that we would potentially launch in that. That's a C5. Then it goes up to an M, and then it goes up to an X. Those are the main size flares. You do get weaker ones that are labelled, but we're not interested in seeing those with FOXSI. So one of the things that we've got when it comes to X-class flares, to go back to what FOXSI can handle, is we've got a good set of criteria with how many photons, how much light is reaching the detectors, and we know that once it reaches a certain level, we have filters or attenuators that we can insert in front of the detectors, and that'll cut down on all of that light making it in, which means that the detectors won't be overloaded, as Julie said, and we'll still be able to get some really good science quality data. So I'm not entirely sure what size of flare that corresponds to. It is in the X range, I believe, when that is, but it would be very obvious in our data display when we need to hit a big red button that says put these filters into place to cut down on that light. And if that is the problem that we have during flight, I think all of us would be very, very happy. So I can pass it back to Julie if she's got any more to add to that.
Oh, yeah. Thanks, Chris. Nothing more to add, but happy to answer other questions.
I had no idea about that, Dave. We had ideas about the permit, but forest fire I hadn't even considered. Thank you for your insights. Sounds good, Dave. Play your beats. It's our pleasure. We love spreading science and information. We got another special treat to answer not keyed in, who asked, the note on FOXSI-4 talks about getting back the equipment. How important is it to recover the rocket? Is it not, is it just not having to make the next one from scratch, or does it give you more data? And with me, I have another special guest, Lindsay from the University of Minnesota, who was the wonderful PI of FOXSI-4, here to answer that question.
Hello, everybody.
So if we don't recover the payload, we'll still be able to get enough data to write a lot of papers. So we'll still be happy campers even if we don't recover. But in order to get all of our data, we have to recover the payload so that we can get our disks where we're dumping everything that we take on board.
So what data would be retrievable without the payload?
During the rocket flight, we're getting telemetry from the experiment, and so we're getting a lot of data down, but we can't stuff all of our data through that telemetry line, and so some of it is going to stay on board and not make it down, and all of the data gets written to disks. So if we recover the payload, then we get everything.
Do you have a fan in the chat? Ace says hello. Do you have a message for Ace?
Hi, Ace. We love you.
So do you have a rough estimate of like how much data we would lose if we don't recover the rocket?
It depends on the size of the flare. So if it ends up being a relatively small or medium flare, we should be able to get all of it down during telemetry. Maybe not the CMOS detectors. So we would not get full data from our soft X-ray cameras, but we would get probably all of our data from our really high-energy X-ray detectors. If it ends up being a big flare, then probably we can only get a fraction of the data down in telemetry, and then we're really dependent on the recovery.
I know. Earlier this integration, Milo was chatting with Becca, our not project manager, our mission manager, about defining what would be the like correct wording to like define what's successful in retrieving the rocket. How important is like wording these NASA documents? Like it seemed like they spent like 30 minutes just like getting the right word to define like success criteria and all that.
Well, if you get the terminology wrong, then there's the possibility that people might totally misunderstand what you mean. So you want to be really careful with what you're saying on comms or in the documentation. You have to make sure to get the words right.
There's a question, Constantinos, Genies. Everything's recovered by heli, correct? I believe that's correct. And I heard that a special 2 people last time got to ride the helicopter? Or do people not get to ride the helicopter?
Sometimes for recovery, there can be team members who go with, but the way it was planned out last time we launched from here, and I believe this is the case this time too, the helicopter is actually positioned pretty far away from us, and so that kind of precludes anybody who's located right here from being able to get on that helicopter. The reason it's so far away, I think it's about a couple 100 miles north, is so that that helicopter can get to the landing site as quickly as possible.
In terms of apogee, I know we were expected to get to around 300 kilometers.
Great truck and red car heading your way.
In terms of how far we are from the landing site, I don't know if that is necessarily known at the time. Oh, I'm getting word that it's around also 300 kilometers. Thank you, Hawks, mystery man. Yeah, I think Lindsay has some work to go do. She's been great. Thank you so much for joining us. I believe she wants to give a little shout out before she leaves.
Yeah, I just wanted to say hi to all the students of Physics 1302, Section 400 at the University of Minnesota. I hope you're having a good time studying for your finals, and I know you're going to do awesome.
No pressure. Thank you again, Lindsay, and shout out to her students. I just want to shout out to the people back at home. Thank you so much for all the questions. They've been great. We're having a great time answering them, so keep them coming.
Yeah, and just to add on what Danny's saying there, we're learning a lot from these questions getting answered as well. Yeah, you're helping a lot here, chat. Thank you very much.
Now, car has
Especially shout out to Dave. A lot of those questions, Dave is just the guy. He just knows, and he's the one setting up the stream and getting the live stream working and all the music. So, really, thank you, Dave, making this a smooth time for us here at the FOXSI Science team.
Well, it's a pleasure, Dave. It's been really fun for us too.
RSO with an update to 138, azimuth 14.6, elevation 80.4.
ACS rechecks 137.
Launcher set to azimuth 14.6, elevation 80.4, recheck 139.
RSO confirms.
Just seeing a question there from Liam Edwards there. Are we in a hold? So I suppose it depends how we interpret that question. At the minute, for FOXSI, we're waiting on solar activity. So technically we are in a hold at T-minus 3 minutes, waiting to pick up the count. When we see sufficient solar activity, but we are sitting ready, waiting to do that. There isn't any issues going on that would prevent us from launching right now. So we're ready to go, and we're holding at T-minus 3 minutes, ready to launch when we see sufficient solar flare activity.
So Chris, why 3 minutes? Why not 2? Why not 4? Like, how did we decide on this time?
That's a good question. One that I can't answer fully, I don't think. So there's pretty much some limitations. There are certain procedures in the rocket. Dave, please jump in here and add more into this if you can. But effectively, there's certain procedures that need to happen right before we launch. You can't do them really early on in the sequence, and so 3 minutes allows for that time. It's on the rocket side, on the mechanical side, but also on the experiment side as well. We need to do some final commanding to make sure everything's ready to go for the observation, and so 3 minutes is as close as we can get to launch to give us that time. So everything's ready when we do launch and observe.
Sorry for putting you on the spot. I didn't know the answer exactly either, but someone a little more senior than me might. But yeah, that's my understanding as well. I'm also noticing that we got Peter PFRR Recovery in the chat. Shout out to the recovery team. It really reminds me like how big of a team FOXSI is, even though we're not the biggest missions or whatever, but we still require a lot of personnel and a lot of expertise from all sorts of people. So we got the science team, which in and of itself is multiple institutes from multiple countries, and then we got the NASROC people down at the blockhouse, and then we got the local PFRR folks back at home supporting us. So FOXSI is only possible with all these different parties all coming together, working hard to get a rocket that will only get 6 minutes of data. So it's kind of amazing how much 6 minutes is in terms of science.
Gray truck heading your way.
I like that merch idea, Climb Here. Poker Flat does have their own set of merch though. Cash only. I don't know if public is able to get access to the store, Dave, but I know I need to go get some cash to buy a shirt or something before I leave.
Truck has passed.
So it's 3:45 Alaska time, or 23:45 UTC, which means you only have 30 minutes left in our launch window today. If we don't launch within these 30 minutes, don't worry, don't fret. We'll be back here again tomorrow. We'll be here bright and early, but the launch window still opens at, I would say, around, I think nominally will be 1900 UTC. If we don't launch, you all again tomorrow.
Yeah, and as Danny said, that this is what it's all about. It's part of the why we do this is we're also trying to make the sun more predictable, learn more about it, and so these sort of long waits are very expected. In FOXSI-4, we launched on the second last day of the campaign, towards the end of our observing window for that, which was definitely had us all on edge. But the sun's a lot more active this time, and there's definitely reason to be optimistic. So, as I said, the sun's a lot more active than FOXSI-4, the last one, which was an incredible success for the mission. But we've also got new, what we call active regions on the sun coming round as it rotates as well that we can't see at the minute. So as the days go on, we'll see more of these regions sort of start to populate the side of the sun that faces us, which gives us a much better chance of seeing a flare, and seeing a flare that we want and we're able to catch and get good signs from.
Off the record, Chris, did you think FOXSI-4 was gonna launch? It's like the last day.
No, by that time we were all sort of trying to put in place, or trying to get extra days at that point. The hours were ticking down, the sun was so quiet, and there was a scramble to try and get permission and people's availability to try and get extra days, and it turned out that we didn't need that at all, so it definitely felt like a close call, but yeah, it happened and it went really well, so I feel it's in a better situation this time with how active the sun is, and like I said, there's a lot of reason to be really quite optimistic.
Sounds good. I won't tell Lindsay your answer.
No, I think you can. I think Lindsay might have far stronger words to explain the situation than myself. I think we were discussing this the other day, where Lindsay was wearing her Apple Watch, and you can tell by the heart rate monitor exactly what her feelings were as the launch windows went on from day to day, and we were getting nothing at all. So I think what I gave was quite the mild version of how we were feeling at the time.
That's really funny. I wish I would love to see like a time series data graph of Lindsay's heart rate when we were decided to launch. Like that'd be amazing. Dave, I know that this is impossible, but next rocket launch, get like the heart rate monitor of the PI going.
And probably for safety reasons, a medical doctor on standby as we're watching it. Excellent, and I feel far safer where we are right now as well. If I had to go down, I didn't realise that. That's really good.
That's amazing news. We got Polaris Bear 7468 asking what motors are lifting this payload, and I just got confirmation from our amazing PM and head engineer here on the science team, Hunter, saying that we are a two-stage rocket. We got a Terrier rocket and then a Black Brant 9, which is a Canadian brand sounding rocket. So those two will be launching our payload into the upper atmosphere.
Block 1 is good. 2 is good.
This is PI. I would like to announce an early warning.
RSO with an update to 138, azimuth 14.9, elevation 80.9 in the winds are trending green.
ACS rechecks 137.
Roadblock, Blockhouse, just want to provide an update. We're still T-3 and holding. PI reported that he does see some active science, so getting towards the end of the window, but stand by, might be some activity.
Block 1 copies. 2 copies.
Launcher set to azimuth 14.9, elevation. That was azimuth 14.9, elevation 80.9. Recheck 139.
RSO confirmed.
Okay, so we're going to go without music for a little while and see if we can figure out what's going on. Could be something, could be nothing. Just never know. So stand by, guys. We're gonna listen in just to the intercom system for a little bit and see what anybody has to say.
Hi there, this is Chris from the Science Centre again, just giving you a quick update. So we're just seeing some rise in solar activity at the minute. So our PI Milo is just looking over all our monitors and all our different graphs of different measures of solar activity. And yeah, we'll be keeping a close eye on that now, and we'll see where it goes. Let's fingers crossed.
There's a gray truck heading your way. 1 copy.
This is PI with a status update. So the early warning was just a small false positive. Solar activity returned to normal.
So, sorry, Joe, I'm just seeing the chat there. We've just heard word from our PI that it looks like the solar activity has just gone back to background levels. We can all be disappointed together here, but maybe the sun's just storing up its energy for a bigger flare.
Truck has passed. Green truck heading your way. Copy. Green truck has passed. Black SUV headed towards you. Copy that. Black SUV headed towards you. SUV is passed.
ACS CUS.
Drink and smoke because they're lazy. They
Quit, sir. It's May 3rd now for your time.
Say again, please.
For your time when you initialize, it's now May 3rd.
Copy, we've already got it set. Thank you.
Okay, Tyler. So I think I messed up last time. I don't think my broadcast actually went out over YouTube. Just the people on range here got to listen to me explain. So why is the timing now? Um, a big part of the timing for the reason right now is due to the fact that our permitting is not 12 months. Uh, we have permits with all the groups, native allotments, the federal government, the state, to impact back on their lands north of us because everything we launch up does come back down. And we go clean it. Um, we pick everything up. In fact, we got the crews up at Coldfoot right now, just waiting to go pick up rocket parts. But so permitting is a big part. And then also when we get into June and July, by sending something up that's on fire and coming back down possibly hot, we don't want to start forest fire. So we probably wouldn't launch much later than the month of May. Uh, June and July things just start getting too dry, and we don't want to cause a fire or anything. So I hope that kind of helps explain some of it. So between permitting, not wanting to catch fire, um, those are probably the big reasons why we wouldn't launch in the summertime. Let's see. Also, I'm going to try to answer: do clouds stop the launch, or does the ceiling not matter? For this, since they're doing solar, and we have no downrange sites with cameras or anything, the clouds won't matter. We'll launch right up to them, get the rocket above the clouds, and then do a science thing. Let's see. Yeah, okay, hold on a second. Okay, so why is the rocket in a box? So all of our rockets that we launch here at Poker Flat are solid fuel motors. If you will, they're a lot like your model rockets, your SC rockets that you would go to the store and buy as a kid and do. Um, Being that it's solid fuel, we have to keep it warm, and we actually try to keep it warm to not just be warm, but to its optimal operating temperatures. Now, if we didn't do anything for heat wise, especially with as crazy as our weather's been here lately, with the warming and cooling, it'll cause expansion and contraction of the metal shell and stuff. It could cause a crack in the grains that are inside the motor. Now, if the grains inside cracked when they send out the electrical pulse, just like the little 9-volt battery you use on the models at home, instead of burning up the middle and the flame coming straight out, the flame would follow the crack and go around. And instead of the rocket going up, flame comes out everywhere, and the rocket pieces and parts go all over the place. So we build the styrofoam box around it. Down at the bottom, you kind of make out the hose is black, so with the black on
Red
the
truck coming your way.
launcher, it's kind of hard to see. But
Copy.
we actually have a heater hose going in, and we have a heater going, and we're just gently applying a little bit of heat to it to keep it at its optimal operating range. Hope that answers that question for you. Let's see. Yeah, I'll also add in that so when we launch, the rocket just shreds that it's just cheap styrofoam held together with spray foam, and the rocket just shreds it, and foam goes everywhere. Some of it gets burnt up and a little crispy from the flame from the motor. But yeah, styrofoam goes all over the place, and then this summer when it gets done melting, if the snow ever finally melts and dries up, we'll get out there and clean it all up and make it all nice and pretty again for the next time we launch.
Truck has passed.
PI, this is CM.
CM, this is PI.
So just checking in here, we were at the end of the blend window for the day. If there isn't any compelling science in the near future, would probably like to go ahead and scrub for the day.
I wish it was. Now there is nothing promising, so we can close the window for the day.
CM copies. Yeah, so we are scrubbed for the day, so we are going to go ahead with our back out procedures. We're going to I'll let Becca run us through the back out procedure for the payload, and then we'll make a plan for either leaving the launcher elevated or bringing it down.
Sounds good.
Roadblocks, block out.
This is roadblock 1.
All right, let's go to Appendix B for launch scrub.
Well, it sounds like it just wasn't our day, was it? So we're going to mute that off. So we will be back at it again tomorrow. Watch the Facebook page, and I'll put on there when we get to going live on the YouTube feed. Let's see what else we got going on. Any other questions and stuff? We'll do our best to answer them tomorrow. A big shout out to the science team. They made today's broadcast just absolutely wonderful, piping in, answering all your questions. I can't thank them enough. They did a wonderful job, and I want to thank all of you for joining us and listening in and asking questions. And we look forward to seeing you again tomorrow. So with that, I'm going to end the broadcast, and have a great evening.